Good morning all of you. Welcome back to a course database management system. So today's topic of video is numerical based on join operation. So in the last video we discussed about different join operation and we understand what are the different formulas that we can use to calculate the number of block access in the worst case as well as the best case. Now in this video we are going to discuss the numerical based on join operation. So let's discuss numerical based on join operation. So this is what problem statement given to us. Let the relation R1 with attribute ABC and relation R2 having attribute CDE have following properties. R1 has 20,000 tuple and R2 has 45,000 tuples. So 25 tuples of R1 fit in one block and 30 tuples of R2 fit in another block. So you have to estimate the number of block access required using each of the following join strategy. So four joins operation we have been asked. First is a nested loop join, block nested loop join, merge join and the hash join. And in this case this relation is given R1 join R2. So here R1 is your outer join and R2 act as a inner join. This is very important thing that you should know. This ordering is very important. Suppose in this case R2 join R1 is given, then your formula is going to be changed. So be careful. You need to see which is a outer join and which one is a inner join. So in the first step you need to calculate the number of block. In this case what is given to us, we have been given what is the total number of tuples present in one relation and what is the capacity of one block. As I told you earlier that our database stored on the secondary memory, that is hard disk, but that database is stored in the form of blocks. Okay, and every block is having certain capacity. So every block is having certain capacity. So in this case we have been given that one block can accommodate 25 tuples for relation R1 and 30 blocks and 30 tuples for relation R2. So first of all we need to estimate how many blocks are there for relation R1 and how many blocks are there for relation R2. So first thing we have to calculate the number of blocks required for each relation. So in order to calculate the number of blocks required for each relation, you can use simple formula. What you need to do, number of tuples in relation divided by number of tuples in one block. So in this numerical it is already given to you how many tuples are there in relation R1, 20,000, and what is the capacity of one block for relation R1, 25 tuples. So 20,000 divided by 25, so 800 blocks. That means what we can say, relation R1 is stored on a secondary memory in 800 blocks, because relation R1 consists of 20,000 tuples and for each block having a capacity of 25 tuples. So in order to store relation R1 on hard disk you require 800 blocks. Similarly, we will calculate the number of blocks for relation R2. In relation R2, we have been given 45,000 tuples and the capacity of one block is 30 tuples. So 45,000 divided by 30, you will get 1500 blocks. So here what we can say, for relation R2 you required 1500 blocks to store it on a secondary memory. So here we have calculated. So be careful. Sometimes directly number of blocks are given in the numerical itself and sometimes blocks are not given. Suppose blocks are not given in the numerical, you need to calculate it by using the simple formula, number of tuples divided by capacity of a one block. So be careful. You need to read the numerical very carefully, otherwise your numerical gets wrong. So for initially what we have done, we have just calculated the number of block required for each relation. Now next we need to estimate the number of block access required for nested loop join. Okay, so for nested loop join, so here as I told you that this sequence is very important, which is a outer relation and which is a inner relation. So in this case R1 is a outer relation, R2 is a inner relation. So R1 join R2 in the given problem is that R1 is a outer relation, R2 is a inner relation. So for this we need to follow this formula. So you need to calculate the number of block access in the worst case as well as in the best case. So already we discussed the formula for each join operation for best case as well as the worst case. So first of all, we are calculating the number of block access required in nested loop join. So in case of nested loop join, what is the formula to calculate the number of block access in a worst case? So number of disk access equals to nr1 into br2 plus br1. This is a formula, and that formula with respect to this order r1 join r2. Suppose in this case r2 join r1 is there, so that formula is going to be changed. So you need to make note of this. So number of disks access equals to nr1 into br2 plus br1. How that formula comes? So this is a formula to calculate number of block access required in nested loop join, in which case? In a worst case. And what is nr1? Number of rows present in relation r1. And br2 means what? Number of blocks present in relation r2. br1 means number of blocks present in relation r1. So in this case, nr1, what is number of rows present in relation r1? In this case, number of rows present in r1 are 20,000. So in this case 20,000 is there. Number of blocks in relation r2, how many? Number of blocks in relation r2, 1500 blocks are there, and 800 blocks are there in relation r1. So in this way we have put the values of number of rows present in relation r1, number of blocks for relation r2, number of blocks for relation r1. So if you calculate this thing, you will find this value. So this many number of disk access required to access this particular suppose you are using nested loop join. What is asked in your numerical? In numerical it has been asked, estimate the number of block access required. How many block access required? Suppose you are going to join relation r1 with r2 by using nested loop join strategy. So we come to know that these many block access required in the worst case. But in case of best case, how many blocks are required? How many block access are required? So in best case, formula is very simple: br1 plus br2. Number of blocks for relation r1 plus number of blocks in relation r2. So 800 plus 1500, that is equals to 2300. That means now how many blocks access you required in the best case? Only 2300. So this is how we have calculated the number of block access required on relation r1 with r2 when you are using nested loop join operation. So in this case we are going to discuss 4 types of join operation, and every join operation have their own formula. By using that formula we can calculate how many number of block access required in the worst case as well as in the best case. So this we have calculated for nested loop join. In case of worst case, these many block access required, and in the best case these many block access are required. Now next we need to calculate number of block access required in block nested loop join. So in block nested loop join, okay, so in block nested loop join, again we are going to calculate number of block access in the worst case as well as in the best case. Now in this case formula is different. For block nested loop join, in the worst case, to calculate number of block access required, formula is different. What is given? br1 into br2 plus br1. So again we put the value for br1, br2 and br1. br1 value is 800, already we know. br2 value is 1500 and br1 value is 800. So in this case you got this value. So this is a total number of block access required to perform join operation on r1 and r2 when you are using block nested loop join as a operation, and that is in the worst case. And in the best case, the formula is same. Best case formula for nested loop join and block nested loop join is same, that is br1 plus br2. So its value is same, 800 plus 1500, that is equals to 2300. So here we have just calculated number of block access required when we are using block nested loop join operation in worst case as well as in the best case. Now next we are going to calculate the number of block access required in case of merge join. Third type of join operation is a merge join operation. So in case of merge join operation, again the formula for calculating the number of block access in base case is same, that is br1 plus br2, so that is equals to 2300. So if you see, in case of nested loop join, block nested loop join, and in the merge join, the formula to calculate number of block access in case of a base join is same, that is br1 plus br2, so their value is same. But that value is going to be changed when you are using worst case scenario. In the worst case scenario, the number of block access required for nested loop join, block nested loop join, as well as for the merge join is different. Now here we see how to calculate number of block access in case of merge join in worst case. So how to calculate this? Total block access required. So in this case, separately we need to calculate number of block access required for relation R1 and number of block access required for relation R2. Then we need to add both the things so that we will get total block access required, because what we are doing here, we are doing join operation based on R1 and R2, but in case of merge join we need to calculate it separately. Before that we discuss about nested loop join and block nested loop join. So there we have seen, we have calculated it combinedly for relation R1 and R2, but in case of merge join you need to calculate it separately for relation R1 and R2, and then you need to add this thing. So let's see what formula you have to use. First of all, we consider relation R2. Total block access required for relation R2, br2 into 2 log base 2. This is important. Most of the time student making mistake over here, they are not considering log as a base 2, but they are considering log base 10 or log base e. So that is different. In this case you need to consider log base 2. You are using scientific calculator to make this calculation, so at that time you have to make adjustment that you have to take a base as 2, not base as a 10 or base as a e. I am specifically telling this thing because I observe that most of the time student making mistake over there, so they are not getting right answer. So br2 into 2 log base 2, br2 divided by 3 plus 1. So what we need to do, we need to put the values. What is the value for br2? 1500 into 2 log base 2. What is the value for br2? 1500 divided by 3 plus 1. So if you calculate this, you will get this value, 2689.35. That many block access required to access the relation R2. Similarly, we need to calculate total number of block access for relation R1. Then instead of having br2, what we have? br1 into 2 log base 2, br1 divided by 3 plus 1. So in this case 800. What is the value for number of blocks in relation R1? 800 into 2 log base 2, 800 divided by 3 plus 1. If you calculate this, you will get the value 12895.22. Now this, here we have calculated total block access for relation R2. Here we have calculated total block access required for relation R1. And finally what we need to do, we need to add both the things. We need to add this value with this value, okay, so that you will get this value 39793.57. so we need to do it round up, okay. So as it is 93, so we can round up 39793, or you can say 794, okay. Either you can say 793 or you can say 794, because we don't want this value in a fraction, we want the value in a decimal number, okay. So here we just forget about the decimal points. So this is what a total number of block access required in case of a worst case, and that is for which join operation? Merge join operation. And finally we are going to calculate total number of block access in case of a hash join. For hash join, only best case formula is given, no worst case formula is given to calculate the total number of block access. And to calculate total number of block access in case of hash join, for best case formula is slightly different, 3 into br1 plus br2. What we observe in case of nested loop join, block nested loop join and merge join, best case formula is br1 plus br2, but slightly change for hash join. In case of hash join, you have to multiply it with a 3. So slight change in the formula for base case in case of a hash join. So 3 into br1 plus br2. So we already know the value of br1, that is number of blocks in relation r1, that is 800. Br2 nothing but number of blocks present in r2, that is 1500. 1500 plus 800, that is equals to 2300, multiplied by 3, so we will get 6900. So that many number of block access required. Suppose you are using hash join operation. Okay, so in this way you have solved this numerical. So this is a very simple type of numerical you can solve. Only thing is that you need to remember the formulas that you need to use to calculate the number of block access required in case of first join. Best case formula is very simple, br1 plus br2, but only difficulty or somehow complex thing is what you need to remember the formula for worst case. For block nested loop join, merge join, in case of hash join there is no worst case formula, so only that thing is there. And one more important thing I told you about this, you need to check the sequence, which one is your outer join and which one is your inner join. According to that, formula is going to be changed. So I hope you understand how to solve a numerical based on join operation. So again at the last I am going to repeat this thing. What you need to do, what are the tips for this? First of all, you need to read this numerical carefully. You need to check whether number of blocks are already given in the numerical or not. Sometimes it is directly given, sometimes it is not given. They have been given number of tuples, so you need to calculate the number of blocks, and then according to this particular sequence, which one is your outer relation and which one is your inner relation, you need to change your formula for the worst case. The formula for best case is same. And again in this case we are considering relation r1 and r2. So in that case, maybe the case that you may consider relation x1 x2, a relation a b, like that. So according to that, notation is going to be changed. So I hope you understand how to solve numerical based on join operation. Thank you.